Q8797. Microbial growth is produced by various forms of microorganisms that live and multiply in the water interfaces of jet fuels. Which of the following could result if microbial growth exists in a jet fuel tank and is not corrected? A. Interference with fuel flow, interference with fuel quantity indicators, and electrolytic corrosive action in a metal tank. B. Interference with fuel quantity indicators, engine seizure, or a lower grade rating of the fuel. C. Interference with fuel flow, lower grade rating of the fuel, or electrolytic corrosive action in a rubber tank. The correct answer is A. When microbial growth exists in a jet fuel tank and is not addressed, it can have several adverse effects. Let's discuss each aspect of the correct option. Interference with fuel flow. Microbial growth can form biofilms, which are slimy layers that can clog fuel filters, pipes, and nozzles. This obstruction hampers the smooth flow of fuel through the system, leading to reduced fuel flow or even complete blockage in severe cases. Interference with fuel quantity indicators. The microorganisms present in the fuel tank can interfere with the accuracy of fuel quantity indicators. This interference can result in incorrect readings from the fuel quantity sensors or gauges, making it difficult to determine the actual amount of fuel remaining in the tank. Electrolytic corrosive action in a metal tank. Microbial growth in jet fuel can produce acidic byproducts as part of their metabolic processes. These byproducts can cause electrolytic corrosive action, especially when they come into contact with a metal tank. The corrosive nature of the byproducts can lead to the deterioration of the metal tank, potentially causing leaks, structural damage, or other corrosion-related issues. In summary, if microbial growth exists in a jet fuel tank and is left unaddressed, it can result in interference with fuel flow, interference with fuel quantity indicators, and electrolytic corrosive action in a metal tank. These consequences can have detrimental effects on the functionality and safety of the fuel system. Q8798. The vapor pressure of aviation gasoline is A. Lower than the pressure of automotive gasoline. B. Higher than the vapor pressure of automotive gasoline. C. Approximately 20 at 100 degrees Fahrenheit. The correct answer is A. Aviation gasoline has a vapor pressure restriction with a maximum limit set at 7 psi. This maximum limit is intentionally kept lower than the vapor pressure found in numerous grades of automobile gasoline. Q8799. What can be done to eliminate or minimize the microbial growth problem in an aircraft jet fuel tank? A. Use anti-icing and antibacterial additives. B. Add CO2 as a purgative. C. Keep the fuel tank topped off. The correct answer is A. Using anti-icing and antibacterial additives provides a comprehensive approach to tackling microbial growth. These additives specifically target the factors that promote microbial growth, such as ice formation and bacterial colonization. By addressing these factors, the additives create an environment that is unfavorable for microorganisms to thrive, effectively minimizing the microbial growth problem in the aircraft jet fuel tank. These additives directly target and address the growth of microorganisms. Anti-icing additives reduce ice formation in the fuel, creating an unfavorable environment for microbial growth. Antibacterial additives inhibit the growth of bacteria and other microorganisms, preventing their proliferation in the fuel tank. By using these additives, the conditions that support microbial growth are effectively controlled, ensuring the integrity and safety of the fuel system. 8800. What is the maximum vapor pressure allowable for an aircraft fuel? A. 4 psi. B. 5 psi. C. 7 psi. The correct answer is A. The maximum permissible Reid vapor pressure for aviation gasoline is 7 psi when measured at a temperature of 100 degrees Fahrenheit. This specific limit ensures compliance and safety standards for aviation fuel. 8801. If a bladder-type fuel tank is to be empty for an extended period of time, The inside of the tank should be coated with a film of A. Engine oil, B. linseed oil, C. ethylene glycol. The correct answer is A. When a bladder-type fuel tank is empty for a prolonged period, there is a risk of the bladder material drying out and becoming brittle. Coating the inside of the tank with a film of engine oil helps to prevent the bladder material from drying out by providing lubrication and maintaining its flexibility. Engine oil is commonly used for this purpose as it has suitable lubricating properties and helps preserve the integrity of the bladder in the fuel tank during periods of non-use. 8802. How may the characteristics of a fuel be improved? A. By adding a knock inhibitor. B. By adding a knock enhancer. C. By adding a fungicide agent. The correct answer is A. Adding a knock inhibitor to fuel helps improve its characteristics. Knock, also known as engine knocking or detonation, refers to the uncontrolled and premature combustion of the fuel-air mixture in an internal combustion engine. Knock can lead to engine damage and decreased performance. A knock inhibitor is a chemical additive that helps prevent or reduce knock by modifying the combustion process. It inhibits the formation of flame fronts that can cause knock, allowing for smoother and more controlled combustion. By adding a knock inhibitor to the fuel, the risk of knock is minimized, improving engine performance, fuel efficiency, and overall combustion quality.